Here we go with example 2. For example 2, charge Q1 has a value of 4.00 coulombs. Going a distance of 3.20 kilometers to the right of that, charge Q2 has a value of negative 6.00 coulombs. Going an additional 2.70 kilometers to the right of Q2, charge Q3 has a value of negative 5.60 coulombs. I'm going to calculate the forces between Q1 and Q2, between Q1 and Q3, and between Q2 and Q3. Well, the forces between Q1 and Q2 are going to be attractive because one is positively charged and the other is negatively charged. So I'm going to just put the minus sign there. I'm not going to bother listing the values on my sheet of paper. I'm just going to plug it right into my calculator. Alpha K times 4 times 6, which I know is actually negative, divided by, I have to convert the kilometers to meters, knowing that 1 kilometer is 1,000 meters. 3.20 kilometers is actually 3,200 meters squared. Doop. My calculator displays a value of 21.1 kilonewtons. So it's actually displaying 21,070.3125, which I'm going to express with Greek prefixes as attractive force of 21.1 kilonewtons. The force between charge Q1 and charge Q3 is also going to be attractive because they are both oppositely charged. So I'm going to put the attraction symbol there, the minus sign. And into my calculator, I go alpha K times 4 times 5.6 divided by, and I'm going to open parentheses because I'm too old to do this in my head, 3,200 meters plus an additional 2,700 meters, close parentheses, squared, enter, and I get 5.79 thousand newtons, negative 5.79 kilonewtons. Last, I calculate the force of electrical attraction or repulsion between charge Q2 and charge Q3. In this case, I see they are both negatively charged, and like charges repel. So this is going to be positive result, meaning they repel each other. And I go alpha K times 6 times 5.6 divided by 2,700 squared, enter, and I get 41.4 kilonewtons of repulsion between charge Q2 and charge Q3. So now you students are going to calculate what is the net force on Q1, what is the net force on Q2, what is the net force on Q3. All right, my students have collectively put down their calculated results, and it's time to see if I agree with them. For the net force on Q1, I see that Q2 is pulling Q1 to the right with a magnitude of 21.1 kilonewtons. Meanwhile, Q3 is also pulling Q1 to the right with a value of 5.79 kilonewtons. So they're both to the right of Q1. They're both pulling Q1. So these two forces add together, and I end up with a net value of 26.89, which I will indeed round up to 3 sig figs and say that it's 26.9 kilonewtons. It is an attractive force, so I'm fine with saying that it's being pulled. Both Q2 and Q3 are to the right of Q1, so it is pulling Q1 to the right. The net force on Q1 is 26.9 kilonewtons to the right. You don't really have to say whether it's being pushed or being pulled. You could just say it is to the right, okay? But yes, in this case, it's being pulled, so to the right. For Q2, the students think it is 20.2 kilonewtons to the right, or perhaps 62.5 kilonewtons to the left. Well, Q1 is pulling Q2 to the left with a force of 21.1 thousand newtons. Meanwhile, on the opposite side of it, charge Q3 is pushing charge Q2 also to the left with a force of 41.4 thousand newtons. So both of these forces are acting to the left, pulling to the left and pushing to the left. Even though they're opposite signs, it's because Q1 is to the left of Q2, so a minus sign means pulling left. Q3 is to the right of Q2, so a plus sign means it's pushing to the left. So in this situation, I would indeed add their magnitudes together, and I get 62.5 kilonewtons to the left. To find the net force on charge Q3, I see that charge Q1 is pulling Q3 to the left with a magnitude of 21.1 thousand newtons. Right next door to it, charge 2 is pushing Q3 to the right with a force of 41.4 thousand newtons. So in this situation, I would take the difference of these. I'm sorry, I'm looking at the wrong numbers, aren't I? You were going to correct me, weren't you? I was looking at force 1, 2, but I'm on charge Q3, so this one is not used at all. Sorry. Now, I saw it because of your answers here. The force of Q1 off in the distance is pulling Q3 to the left with 5.79 thousand newtons. Next door to it, charge 2 is pushing Q3 to the right with a force of 41.4 thousand newtons. So indeed, I have to take the difference, 41.4 minus 5.79, rounded to 3 sig figs, is indeed 35.6 kilonewtons to the right is the net force on Q3.